Hello, everyone. It's really a pleasure to be here. Thank you, Marius, for giving this spot. I think I've got something very interesting for you guys today. Unfortunately, my remote control isn't working. Darn Apple technology, so I'll have to stand behind here. I apologize for my voice, and it's a bit harsh, but I have a cold. I've been self-medicating for the past 3 days, and with mixed results. We'll see how that works out in just a few minutes. Due to this cold and the way that I'm feeling, I'm not going to be able to do my usual song and dance routine, but I've got something equally interesting. So I'm a big fan of CheckMK, as is obvious, and I'm also a big fan and a big believer in self-healing IT systems. And I want to show to you what me and my colleague George did for this presentation in just 2 days. So everything that we have here we did in basically about 2 man-days worth of work. Before I get into details, I'd like to present a little bit about ourselves. So we're an IT service provider with a twist, as I like to call ourselves. We do a bit of development, a bit of systems engineering, lots of system administration, so your typical break-fix support for medium and large companies. We are what we like to call a full-stack IT monitoring service provider. This means that we are fully dedicated to CheckMK, but we extend it so that we monitor the entire stack. So from the operating system, the hardware, networking, and to application level metrics, so that we give you basically a single pane of your entire IT infrastructure. And if you're wondering why yesterday during Marius's starting keynote you saw Romania in the list of subscriptions, it's because there's a very, very CheckMK friendly partner there, and that's us. I felt very strange when I saw Germany, US, Austria, Romania. So it's good. Our country really loves the product. It's great. And once again, good job to the CheckMK team. So that's our first line of business. We do monitoring. We have a firm belief that if I can't monitor it, then I can't improve it. I don't know which way to go. So we always measure and we make sure that we have metrics consistently before we make decisions as which way to go with our IT infrastructures. We do a bit of cloud, and in the cloud area, I'm talking about automation, deployment to different virtualization technologies. We're really big on the whole containerization thing, and we're also a Red Hat, we're the only Red Hat Premier partner in Romania. We work with Red Hat and their products, but we're really, really open source friendly. So if it's open source, we're there, and we're really trying to take it to the next level. We're also a big fan of high performance computing. So both personally, me and my team, but also as a company and as a philosophy, we believe in being focused and getting the most out of what you do. We've partnered with SGI, Silicon Graphics, and we are, if I'm not mistaken, the only authorized partner to do HPC solutions in our market. We've done a little bit of security, mainly through the aspect of integrating CheckMK with log management and CM solutions, and we've found this to be a great fit. So we can integrate with Elasticsearch, as you saw yesterday, and Logstash, and we can get you really, really interesting metrics out of those and present them to you in the graphical user interface in multi-site. And recently, we've added training to our plan, and this is through the great partnership with Marius Kenner and his team. Just last week, I did a 5-day training for a classroom of about 20 people, and that's probably where I got this cold as well. But we're doing that now as well, and a little bit of coaching for, let's say, more advanced subjects where somebody wants to get some higher level knowledge. They call us in, we sit down, and we do some on-the-job training. So that's about us. That's a bit about us. We love CheckMK, as I said. We really love it. We think it's one of the best pieces of software we've worked with in a long time, especially in the IT monitoring area. And we have a couple of initiatives of our own. I recommend you check out our website. We've got tutorials and how-tos for doing simple stuff, deployment, and maybe more advanced stuff. We write few checks, quite a few. Some of them we provide on our GitHub page, some of them our clients provide on their respective pages, and you might find some interesting stuff there. We're doing a translation, and I know it should have been done a long time ago, but I was very, very optimistic as to how quickly we could translate, but it's difficult. I don't think this is of much interest for you guys, but there's a couple of older fellas in the Romanian in Romania that are just waiting for this. It'll be done soon. And I started a documentation effort on my own about a year and a half ago. Unfortunately, I don't know where I left it off. It's on my GitHub page. It's also synced with Read the Docs, and you've got some standard documentation for adding Linux hosts and doing stuff. So I feel it's complementary to what Matthias has on his site. Good. Now, this presentation there's going to be a live demo, and hopefully the Chaos Monkey will not show its head today, but I want to share with you how I feel about IT. So I feel technology is a tool, much like your shovel, and it's supposed to make my life easier. Just like the shovel makes my life easier, I don't have to dig holes with sticks or with my hands, and I feel exactly the same way about IT. Any new technology that comes into my life, I measure it as a tool, and I say, how are you making my life easier? And if it's not, I throw it out. Yeah, so that's basically it. And I've always been looking for ways to do that, to enhance my life using technology. And you have to realize that I've been a system administrator and a system engineer, so that's the perspective I'm looking at this making life easier idea. So I've been toying around with self-configuring systems, basically automation, and self-healing systems. How do I get those systems to basically heal themselves when there is a problem? And I've set a very, very low bar for myself. Just in case it doesn't work, I don't feel so bad. So I say, if in a typical IT infrastructure, I can eliminate 10% of the things that break by having them automatically repair themselves, then I'm a winner. And I'm happy to say that I've got 10%. I think we could do a heck of a lot more, and hopefully this will be the beginning of something very, very interesting. There's a disclaimer or a caveat here. Some things do not work properly. We're using some pretty beta software here, some of it alpha, some of them are scripts that I wrote in my heavily medicated state these past 2 days. One of the scripts George just wrote this morning, so take that into consideration, take it with a grain of salt, and know that if we were going into production, these would be a lot cleaner, a lot more documented. Good, so some things are a bit ugly. Take that into consideration as well. My scope wasn't to have clean code, but have functional code today. And security is an important aspect, obviously. We think because the way we're doing it here is via SSH. We're already using your existing PKI infrastructure. We feel pretty good about that. So your mileage will vary on what you consider secure and not. Okay, so to get what I wanted, I've been looking at a simple feedback loop. Basically, the outputs of one system are the inputs to another system. And I'm a big fan of simplicity, so I try to simplify things down to their least, to as simple as I can get. And after playing with many different types of configuration management tools, Nagios event handlers, the whole lot of it, anything that I could do to automate I've played with, I finally settled on Ansible. And I'll get into a couple of details about Ansible in just a few minutes. And obviously, I use the awesome CheckMK software to monitor. And this, to me, provides a very simple feedback loop. CheckMK catches errors, feeds them into Ansible. Ansible will try to repair them. And you'll see where the overlap is now with the great alert handlers provided with 127 Innovation Branch. So, a bit about Ansible. Ansible is an IT automation tool that can configure systems, deploy software, orchestrate advanced IT tasks, do continuous deployments, or zero-time rolling updates. Now that's a lot, and it was written by the guys at marketing for sure at Ansible. But Ansible does a few things exceptionally well and exceptionally simple. First on that list is configuration management, and here we're talking about keeping things simple in your processes for deployment, provisioning, and general configuration of your IT infrastructure. Competing products, as I'm sure some of you may know, have gone completely the other direction. They're more complex, they're cumbersome. You have a steep learning curve. You have to set up an entire dedicated infrastructure just to have those tools running. Ansible does continuous delivery. This fits in with the release early, release often mantra that the guys in Silicon Valley are all talking about. sure, we're not all Twitter, but we do want to have software released as early as possible in a seamless fashion. This helps us push the software through its life cycle phases in a very, very easy manner. Application deployment, and here we're talking about simple applications, single binaries that you just need to place somewhere, up to multi-tier applications that could comprise of hundreds, maybe thousands of components. And the reason Ansible does this so well is because of its simplicity. We can do provisioning. This is a big one for us because we're now starting to see an uprise in cloudy environments, so people are not, they're treating their servers as cattle, not as pets, and it changes. It's a paradigm shift for us, and we need to be able to bring up systems anywhere in the world, with any provider, with any virtualization or containerization technology, and we can do this once again simply and efficiently. Hopefully you'll see an example of that functioning today. And finally, security and compliance. This is important because you need dependable and repeatable procedures that you can push out into your system. So that's a bit about Ansible. This is how I and my team feel about the integration between CheckMK and Ansible. So first of all, we model our IT infrastructure using Ansible and so-called playbooks. Others call these recipes. The idea is that, and I can't put enough pressure on this point, it's very important, we literally define what our servers should look like and what their desired state should be. And I get down to the nitty-gritty details. So I model everything. So if I'm running an SQL setup on there, I will configure it, I will remove unwanted users. So it's basically like you're sitting down and configuring it. The more detailed you get into it, the better your results will be. And then CheckMK ensures that my state is enforced. So, and this is something we're working on, we need to get a one-to-one mapping between what we define in Ansible as our desired states and what CheckMK receives on the other end. So this is where we're working at creating sort of a mapping table, if you will, between what I define in Ansible and what CheckMK sees. And it's a work in progress. We've got some good ideas in this direction, but it's by no way finished. So this is what my feedback looks like, feedback loop. It's very simple. I love simple stuff. I could make an argument that we could introduce another step, but for the majority of infrastructures, this is simple enough. And it'll cover the majority of workloads. So we model our systems. We call this the deployment phase. We then push those systems out, so systems are bringing themselves up online in clouds, on virtual environments, wherever you may be. We then monitor the systems completely, and completely meaning that we'll write CheckMK plugins, local checks if necessary. We'll do whatever we have to do to make sure that we get every piece of information out of those systems that is relevant to ensuring our state and model. And then we ensure that state continuously, and this is where CheckMK and Ansible overlap. And you'll see the alert handlers, and then CheckMK will, alert handle will trigger, CheckMK will pass that off to Ansible, and then Ansible will go back to the deploy phase and basically ensure our state. This is how it looks like more specifically. As I said, there might be an argument that could be made to adding a third phase in the CheckMK Ansible phase, and this really is applicable if you have large infrastructures. You could integrate a cluster management solution such as etcd with a registrar. We've seen Console being used, Zookeeper, but these are already just hyperscale IT infrastructures, which we love, and we do work with some of those, but it's a bit of an overhead. But it could be there. So, before I get to my demo, I need to make sure we understand some of the terminology so that you can follow along with me during the demo. Ansible uses the following concepts for orchestration. We've got a simple inventory file. Think of this as your hosts file. You just define host mappings. Alternatively, you can use an inventory plugin, and there's quite a few in the wild, but it's very easy to develop one. You can plug into your CMDB, an SQL server, an LDAP server, and coincidentally, we realized that we can plug into CheckMK fairly simply. So we can use live status queries and pull all the host and tags and whatever else is necessary and build on that. Or by accident, I discovered that you can do a CMK minus L and you get a nice list of your hosts. So it's very easy to integrate it with CheckMK if CheckMK is your single source of truth for what's out there in your infrastructure. Good. We've got playbooks. This is the heart of Ansible. This is where these are the orchestration blueprints, as you will. Others call these recipes. And finally, Ansible provides you with ad hoc parallel command execution. Now these are things that you probably don't need a playbook for, so maybe you want to do a mass reboot of all the servers in your data center or something. This would be the way to do it. This is my inventory file, or an inventory file. Hosts, as you can see, can be grouped or ungrouped. The square brackets define groups. I can define some variables. And I can also define ranges. And I can define groups of groups. So my southeast has the colon children separator, and I'm saying that anybody in the southeast group should also, anybody in Atlanta should also be in the southeast group. You can define any variables here that you want. I usually recommend don't define more than 5 or 6 variables here. There's a better place to do that. I can also define what we call, it's a sort of piggybacking. So if you look at the jumper host under our web servers, I'm telling it that to connect to that host, you connect via a different port in a different host. Here's a very, very simple playbook that tells us that the hosts in the web servers and the hosts in the load balancers group should inherit 2 roles, the common role and the load balancer role for load balancers, content for web servers. Order is important, otherwise they would not apply in this case. Here's a part of my common role, which tells us a couple of good things. And this is probably a good time to point out that Ansible is using YAML. This is a YAML format if you're not familiar with that. Coincidentally, YAML in Python, who would have thought, it's a match made in heaven. They work very great. The syntax is simple, but what's interesting for us is that this is self-documenting. This is documenting my infrastructure. So I've written a blueprint, I've written a playbook. Now that serves as documentation for the rest of my colleagues. We all now know what we're looking at in my infrastructure. We're telling our common servers that they belong to the common roles and that they should have NTP installed. I'm tagging everything just because later on, as I apply state enforcement via alert handlers, I don't want to apply the entire playbook. I want to apply just a specific part. So let's say my NTP server fails, CheckMK picks that up. I don't want to run the entire playbook because it could take several minutes. I just want to execute the NTP configuration again. So that's why we use tags. I'm using a service module to make sure that NTP is started as well. I'm using a template, which is using the Jinja 2 format, and these get compiled just in time with variables that you've specified throughout your playbooks. And I'm specifying an alert handler. This is, Ansible calls these handlers by using the notify stanza there, and basically we're saying that if the template gets uploaded, then restart NTP. This is what the handlers look like. It's very simple. You can obviously define more complex ones, and you're encouraged to define more complex ones, but for restart of a service, this would be it. And I would just add one more thing, that Ansible does something called idempotency, meaning that in our example here with the template, so it will push that template, it will see that it changed something, it will restart it. If I run the playbook again and it doesn't change anything, it's not going to blindly restart our services. So this is a good thing. Okay, In this particular case, I've set up a demo for you, and I'm going to be deploying to what is called a SmartOS Linux containerized environment. First, it's not Linux. It tastes like Linux. It looks like Linux. It smells like Linux, but it's not Linux. It's running in a Solaris zone, something under an LX brand. And this is what the environment looks like. So I've got one load balancer, 2 web servers. I skipped the database here because it's self-explanatory. And I forgot to add, there's also an OMD instance in there, which unfortunately I didn't have enough time to add the icon to, but know that it's there. And I'm not going to be bringing up the entire internet. I'm just going to run a small network on my laptop. The idea is that we're using this particular SmartOS technology. We could use whatever we do with Amazon, with Hyper-V, if you really want to, anything. Good. So, the end of our deploy phase is where we signal the installation of our CheckMK agent. And we do this using Vato Web API. We assign any necessary tags. We create the folder. So we do everything that you would do if you were there configuring your system manually. We then move to the enforce phase, where basically we pass everything off to CheckMK and say, alert me when there's an issue, or not, even better. Try to resolve it yourself and then alert me. That's actually the way we do it. So it will try to resolve the issue. If it can't, then I get an email, which is good, because if it wakes me up at 3 in the morning, I at least know that it tried to do something. And then in the enforce phase is where we basically just pass it off to Ansible and say, run this playbook with these tags and try to clean up this mess. This is all pretty basic stuff, right? It's just a glorified alert handler. And we've been thinking about that as well. What's the difference? It's just an alert handler. Well, take into consideration the context. I'm deploying maybe large infrastructure, multi-tier applications, so there is value in tying it in together. But we thought of a way we could get a little bit more value out of it. And we thought about doing some scale up and scale down scenarios. We monitor everything, so the data is there, the metrics are there. I know when my load balancer is overloaded, I know when my web servers are down, I know when my database can't handle any more IOPS. So what if I take those metrics as input to an alert handler, pass those on to Ansible and say, hey, there's a problem over here, bring up another node. And on the other side of this discussion is downscaling. Okay, I see that I'm no longer in the red. Let's start taking some nodes off. And we've got some really good first steps in this direction. Unfortunately, the script we just finished less than 15 minutes ago, or maybe 30 minutes ago, and it's not completely functional, but I'd be more than happy to present that. Everything will be up in our GitHub account, and let's get to the demo. Like I said, let's hope the Chaos Monkey leaves us alone today, because I've had enough trouble with this cold. Okay, so I've got a load balancers, 2 Apache web servers running Linux. I've got an OMD instance which I deployed using Ansible, but I don't figure I have enough time to show you the entire deployment, so I deployed it early. But if you want to see the playbook, catch me afterwards and I'll show it to you. It's very, very elegant. It's an empty site, as you can see. The only thing I have done is created an automation user, and sorry guys. The monkey, yes. Arrangement, mirror. Okay. I felt like a magician. I had a magic card hidden in my sleeve and I just did some magic here, but no. So I've got my OMD instance here. As you can see, it's empty. The only thing I have is these alert handlers, which are disabled right now. I won't be able to get into details about the scale up and scale down, but we'll talk about these if you find this interesting. But we can talk about a simple service event handler and an instantiate script, which will basically rebuild a server from scratch on whatever cloud platform you want or physical servers. So while I show you the actual playbooks, I'm going to run here an Ansible command, Ansible playbook. I've got a special inventory file, which is this here, and I'll get into details. Yes, I can. Is that better? Even larger? Okay. Sorry about that. Good. So I'm basically saying use this inventory file here. I'm going to run a site-wide playbook. I want to limit it just to these two hosts. I want to run this as root. But before I do that, I need to create some servers because I don't have a system to provision. I don't have PXE boot here or a real cloud platform. So on my SmartOS server, you can see that I have no servers. I've created a quick script that will create 3 servers for me. It will insert my SSH keys into those servers. Now this could be easily done with Ansible in less than 5 or 6 lines of YAML code, but I just didn't have the time to do it. So I'm creating these 3 servers. I will have these, okay, as you can see, they're already up. As you can see, I am not able to log in with my own user. So if I try to log in with Web1, ignore this because I've been rebuilding and destroying these so many times that you've got some errors. But I can log in with root. I have no checkmk agent. I have no HTTPD installed. So it's basically a clean system, clean CentOS Linux system. So now that I've got those systems up, I'm going to run my Ansible playbook on these 2 host groups. And as you saw, I can log in with root without authentication, so this will work. Limit does not match any host. That is great. I have 2 times -L. You are right. Thank you so very much. It's due to the self-medication. Okay, the only thing I want to show you from this output, it will take about 3, 4, maybe 5 minutes, depending on what Apple is doing behind the scenes. The only thing I want you to gather from this is the gathering facts section. This is an important step. It's literally pulling information from all of these servers and serving it up to me as variables that I can then reuse throughout my playbooks. If you skip this step, things will go a lot quicker, but then you end up having to hard code certain things. You get into a chicken and egg problem when you're deploying new servers. So this is my inventory file. I make this a little bit bigger. This is all on one line. I hope that you can see that. Basically, I'm defining a host here and telling it this is the SSH host that it should connect to, and I'm defining another variable called a folder. I'm assuming that you know that these folders I'll be reusing later while I'm applying this configuration into OMD. Let's look at my site.yaml file. I've excluded OMD from this because I've already had it installed and I didn't want to redeploy it. I'm bootstrapping my server, so this is basically where I say simple stuff. Make sure I have my SSH keys deployed, make sure that NTP is synchronized to the right servers. Then I go to my web servers and load balancers. Let's take a look at my bootstrap. I'm telling that this applies to all hosts, hence the name bootstrap. I want all of my hosts to be bootstrapped the same way. I'm using a couple of variable files here. So I'm using this one from the common role and then this one from the OMD role, and I'll show you what they do exactly in just a minute. And then I'm saying that all the hosts that are getting bootstrapped should have the common role applied. And now we can look at the common role. I don't know how to make this bigger, so it's pretty small here, unfortunately. But this is a fairly standard structure for defining your roles. You have a files section. This is where I placed my SSH key. You have variables, and here's what my variable file looks like. I've only got one user that I want to add, but I can also add users to delete, which is great. So if a consultant leaves the company or something and I need to remove his key from all of our customer systems, I do this in a very simple and elegant step, and I'm telling it which public key file to use. The heart of the playbook here in this case is my tasks, where I'm telling it to install some basic Linux packages, NTP, Apple release and whatnot. I'm tagging everything, so if I want to reuse these and and I have to, let's say, bring up a new server, but I don't want it to be part of the load balancer group or whatever, I just say install these packages with a tags switch to my Ansible playbook. So I'm basically doing some very, very simple stuff here. I'm adding users, I'm adding SSH keys, I verify if I need to remove users, add myself to the sudo group. I'm installing OMD here, and this is where I'm using some of the variables from the OMD roles. So if I open the OMD roles and the vars file, you can see that I've defined my automation user, my secret, a host, the site, and a package that I want to reinstall. Now this could be infinitely more complex if you want it to be, but for this test I think it's just fine. I need the RPM package, the site automation user, and the site IP. Now this is how I'm using the Vato Web API. This is not the most elegant at this point, but it works, and it works splendidly. Ansible supports something called getURI, which I could do a bit more complex things. So I could do, for example, exception catching. So I could catch exceptions, I could catch errors, and then react to those errors. Because the software works so great, there's no errors, I could do this in this demo. And I think we're using this in a couple of areas in production as well. So it's fairly stable. And then once again, I'm tagging it. And then I'm using a notify handler because after I add my host, I want my services to be discovered and applied. And I'll show you my handlers in just a second. So I've got simple handlers to restart services. And then I've got these two to use to do the discovery and the application. So it's fairly easy stuff, fairly simple stuff. Depending on my topology and the way that I've set up my variables and hosts, obviously I could create folders here and do other stuff. Good. So my playbook just finished just in time. I think everybody got a fairly decent idea of what playbooks look like and what happens behind the scenes. There's obviously more complex stuff behind the scenes, but generally that's it. That's what you do. You define simple commands and you say, this is what I want you to do, and it returns back to you whether it did it and it was okay, and how many things changed. And it's a great way to interact with your systems. So now that it's up, I've got this simple curl command here, which is polling my load balancer here. And as you can see, the load balancer is doing its stuff and balancing between those two hosts. I can show you in my web interface here. You can see here that it's balancing between them two. Safari has an issue of caching. As you can see, it hits the same server twice. It shouldn't do that, but here it's doing it correctly. I can also take a look at my HA proxy status page, and as you can see in the total area here, it's incrementing, so it's balancing stuff out. Now all of this was done with a very simple script. It took us 5 minutes to deploy this. Hope that means something to you. It does to me, and this is one of my independent nodes. Also, my playbook added my hosts very elegantly, very quickly. Added my folders the way that I want them to. I can take a look at my services, see that it's up. It also installed an Apache plugin for me. How am I doing on time? Good. Okay, so it did everything I wanted it to do. Now we're in the monitoring phase. If something fails, and in a production environment, I would not even have to lift a finger because, well, it would push it back into the deploy phase and it would repair it. I'm using simple alert handlers here. Please note that you will have to do a little bit more work than I have done here when you execute an alert handler, meaning that when things break, it's usually not as simple as restarting a service. When things break, you usually have to redeploy some piece of software, do a sweep of access rights. Software breaks in crazy ways, so you will have to do some troubleshooting manually and then write that down into a playbook and then use it as an alert handler for the future. But we're working on a database of ways that software can break for simple things such as HTTP processes and whatnot, and hopefully that'll be up on our GitHub page in the near future. This is a good time to demo the alert handlers. I've got two alert handlers here that I'm going to activate. Once again, these are simple examples. I've just placed a services script in here, and I'll show you what that does. I'm matching on the following services. This is where we want to focus our efforts, and hopefully somebody from the community will come up and help us to find a way to map services from Ansible to CheckMK. So if there's like a mapping table where we're thinking about using tags. So we're thinking about tagging our hosts with every application that's in there, not the most efficient way, and then we could use those tags in Ansible, and whenever a service fails, we grab its tag and we know exactly what to look for. That's, I think, sort of the big hammer solution, but we're trying to iron this out. Take into consideration that this is just a simple example to show you how these alert handlers work. So I'm matching on Apache services. I'm matching on the following event types. Going to save that. I've got a bit more complex one here. Matching on my load balancer, and I want to match on a down state. Now this is actually a scenario that we see happen in large cloud infrastructures. Load balancers mysteriously disappear, or they do crazy stuff, and we need to redeploy them quickly. Save these changes, and I'm going to go here, and I'm going to kill my load balancer. So these are my virtual machines. I'm going to take my load balancer here and delete it. When this happens, this should break. So as you can see, my load balancer is no longer responding, which is good. In a few seconds, CheckMK will pick up on this. It already has. And since I'm a big fan of tailing logs, I can sit here and see what it's doing. But I'm not going to do that actually. I'm going to let that run in the background, and I'm going to show you what my script looks like, so you get an idea of how easily you can create alert handlers with Ansible and a little bit of SSH Kung Fu. Local share CheckMK alert handlers, and I just killed that. So first of all, I'm cheating here. I should have done the playbook, but I really did not have the time. Ansible has great integration with whatever you want, but I felt that it's a lot easier for me just to SSH over to my SmartOS host and issue a command. I'm not doing error checking here, error handling, so probably don't want to use this in a production environment, but it's great for a demo environment. And then after I create that load balancer, I want to make sure that it gets the load balancer role applied so that it gets its configuration, it's back online and functioning the way it was. Okay, if I run a VM list again, oh, what's happening here? Maybe I did not save it. I did not save it. How silly of me. That was not the Chaos Monkey. That is what we call PEBCAC. Problem exists between keyboard and chair, or in this case, standing up. So, I'm very curious whether it will apply this now. Very, very curious if it will do it again. If not, I will have to. I think I have to change that script. Like I said, we're just now starting to use the event handlers. Before now, we were the alert handlers. Sorry about that. We were using the flexible notifications. And I don't know if I have to match. If I don't restrict it here, does it mean that it only runs once? That's okay. Okay. Good. I'll set it up again. I can fake the up state and then fake the down state. That's a good idea. There's no need to fake. Host up, host up, host up. I'm working on this. Up. And it's up now. That's great. It's it's from the medication, guys. It really is. I did this in the training course last week, and everybody was happy with what I did. So are you saying that now? Okay, there it is. It started handling. Great. Not really sure what happened, but it's okay. So the idea was I didn't activate my service handler. If I run VA list, you can see that it created my load balancer, and it's deploying the load balancer role, and in a few seconds it'll be back up online. I can show you my load balancer role just so you get a very quick idea of what's happening there. I'm deploying an HA proxy configuration file which has some variables in it and some very interesting alert handlers which are not functioning now, but I could add new backends and front ends to Ansible based on feedback that I get from CheckMK. So CheckMK tells me through the Apache status plugin that, hey, I've got no more open slots. There's no way I can scale that server up anymore. So I tell Ansible via an alert handler, bring up another web server. And it will do this without, it'll be a sort of a rolling update. Continuous integration is actually the better word. So it will add a new backend to my HA proxy, it will reload it, and then it'll start distributing that load. And conversely, when I downscale, it will pull that host out of the pool and move any sessions that are necessary, or do whatever housekeeping task is necessary, and then kill that virtual machine. Okay, so my load balancer will be back online in just a few seconds. I think I've got another 10 minutes, so if there's any questions, it's probably a good idea to start working on these now. If not, I'll jump into my song and dance routine. So there's one question there. No question? Sorry, that was a mistake. That would have been funny, sorry. Okay, so this will be up in just a few seconds. I think it's done. If I re-inventory stuff and, well, refresh, it's not done. It's going to take a few more seconds. Yeah, so basically that's about it, guys. I could do the same thing for services, and it works a little bit quicker. I think I'll show that. Service HTTPD stop. Like I said, services usually don't stop this elegantly. Usually when they break in crazy weird ways, but for our example, it's simple here. And we should probably see this server offline, or this service offline, and it is, and in a few minutes it'll be back up online. Now, yeah, there it is, the object handler, the Apache handler is now running on this service. So we could sit here and we could see Ansible. We'll see it log in, we'll see it push some Python files across. We'll see it restart my service. I really want this to finish, but I thought it would be a little bit faster. Here's the web servers where it just ran. The output is great from the alert handlers. I think it's really good. I can see that a value was changed. My Apache service is once again back up online. I think my load balancer should be back up online as well. Yep, and we're back online. Phew, not that bad. So, am I finishing too early? So I think I have a mission. My mission was accomplished. I feel that if I stand up much longer here, I might faint. Not from the effort of doing this, but I really am taking all sorts of crazy medications. If there are no questions, or if there are any questions, I'd be more than happy. One question to try and answer it.
Pretty amazing stuff.
Thank you.
I'm really excited about that opportunity, or that combination. I was trying this myself a couple of months ago, and I basically had two major problems to achieve a similar setup. One was to retrieve inventory data from CheckMK. We are still using, I guess, 1.2.4 in our production environment without the Vatos CGI. So I had some issues to gather the configuration data and live status data from the machine. And the second major problem in really using Ansible to its full capabilities was in a distributed setup with multi-hub connections to a remote host. I had in the beginning difficulties to set up the SSH connection.
Sure.
What are your solutions for these two problems, let's say? What have you done to
So
overcome these?
the
I mean,
se-
the first problem is obvious. The web CGI should,
Yeah,
but the CGI should provide most of the information.
of course. So the web API will definitely help you there. For the second issue you brought up, I have not taken this into a distributed setup yet.
Okay.
But from my understanding, and in the clients that we're working and testing this out with, they have dedicated management networks, and we can just extend that to the central site, and these will all get handled from the central site.
So do you have remote Ansible installations from which you drive the local?
No.
Not.
Just
Okay.
one Ansible installation, and it's usually the way I recommend it, because I'm a simple type of guy. I recommend that you put it on the OMD server as well, and this is where there's discussions online about monitoring, executing actions and
Yeah.
whatnot. But
So basically, what I came up with in the end was a combination of SSH proxy commands
yeah,
plus agent forwarding,
okay,
which lets me use my initial SSH key on the Ansible machine
sure,
for authentication on the backend machine, which may be 3 or 4 hops away from my original management station.
I understand.
But that's yeah.
I expect to have the same issue you do with some of our common clients, because they have large telecom type networks,
Yeah.
where right now we're just deploying into one department, and it's simple because it's all there. But I expect as we get to the more esoteric equipment, the more telecoms typical equipment,
Yeah.
they're not going to give us that same access. So we're there. We're probably going to have to use jump hosts, as we
Yeah.
call them, and proxy those requests somehow.
Do you have a Ansible dynamic inventory
No.
library available which connects to CheckMK, or is it?
No, but I think I could write it by the end of this conference.
I would be curious to see the
And,
results.
and if I can't do it, my colleague George definitely can.
Okay.
It's actually fairly simple. I'll do my best to try to get this.
Okay.
After this presentation, I'm going to take a 5-minute
Yeah.
nap out there, and then
Yeah.
get back to work.
Okay. Would love to see the results. if
Sure.
it's
So if I
possible.
can't get it done here, let's exchange business cards. I'll give you
Yeah.
my GitHub account. We're really active in this area, and I think we definitely want to get this done. We
Yeah.
want to do it in 2 ways. One directly with the checkmk -l command, which just gives me the host. That's
Yeah.
easy. And then the other one was to query live status and
Yeah.
then do some interpretation of the tags and see how we map those maybe to a folder structure.
Okay.
It's crazy interesting what we could do there.
Yeah. As I said, my approach comes from the pre-Vato CGI era, and I was actually using part of the CheckMK code to read in all the files, generate Python constructs or objects, and then add also live status data to it.
We're doing this, or we're thinking of doing this for adding tags, because tags is just a Python dictionary, and auxiliary tags, and we can read that into Python, add, update, whatever. I don't know if Matthias likes this or not, but we'll hopefully it'll be okay. I was looking at him to see if he can throw something at me. So, yeah,
Okay. Thank you very much.
thank
Thanks.
you. Anybody else? There's one more in the back.
What happens when Apache breaks every 5 minutes?
Can you say that again? Sorry.
What happens when Apache breaks every 5 minutes?
Well, that's a problem. I haven't been in that situation yet, not with this setup, but we do have systems that break every 5 minutes, and we usually disable notifications for those systems. It's not elegant in what you want to hear. So this is not a use case I have had to deal with this in this particular setup. I'm assuming that we're going to introduce the necessary logic to attempt to repair it once, twice, 3 times, and then we're going to finally give up and say, okay, you've broken this many times in this amount of time, let's call a human to resolve this. I think that's how I would go about it now. Hope that answers your questions. But I would fix that Apache instance. if it breaks that often. But I understand software breaks, yes, we know. Okay, guys. So that was my presentation. I hope you'll find something useful in this, if not at least as an alert handler, if not for the entire orchestration. And it was great to be here for this past hour. Thank you.